Okay. Apparently, there's a lot of confusion about how to do the tabular analysis in this lab. It's very simple. Just watch how you do it. It's very simple. Okay, now you're going to have values here. These are the measurements you get from that little cartoon experimental physics lab, right? Where you measure the angles. And so you got your angles up here, and you're going to take the sine. Now you need to convert them to radians, and then take the sines and put those here. So this is sine theta incident. That would be in air. This is sine theta transmitted. This is in glass. Now you're going to have numbers here. So to get in, what do? You just say equals A17 divided by B17. All there is to it. You tab out, and I don't have any numbers there, and then you grab it. It turns to the right kind of cross. You pull that down and get all of them. You know how to do that. You should. Now, let's say you get a number here, which should be 1.49. It should be close to, I don't know, 1.48, 1.49, 1.50, 1.51, something like that. It'll be close to 1.5. Now, how do you get the speed? You say equals the speed of light in vacuum or air. That's 3e8 meters per second. We're going to use scientific notation. Divide by this number. Boom. See that? Look at that. And then you pull it down and get all of them, because you'll have every one of these cells will have an index of refraction that's associated with its measurements over here. So then you pull that down, you get all the speeds. And then wavelength, say equals. Now what's the wavelength in air? It's 650. See over here, you got all your information. 650 nanometers. Divide by the index of refraction. So what do you see here? What's the lesson? Well, the speed and the wavelength both get reduced in any medium, and they get reduced by the basically directly inverse proportional to the index of refraction. And then you can get those values. And then of course you need to whoops, I just messed up here. Sorry. You need to get your averages. Make sure you average this to get the average in, average this to get average speed, and average these values to get the average wavelength. Get your standard deviations, and then you should be able to do your tabular quoted values right here. You look back at the speed of sound to see if you can do that right. I'm going to say who's getting this, who's learning it, what's going on here. Okay, that's enough hints. I believe those are sufficient for you to get, I think you should be able to complete it pretty well from there. Have a good night.